Hello everyone, now we are going to implement 32-bit up and down counter. So click on create project and click on next and change the project name. Click on next and select boards. Now here I am using Zinc 20 board, so I am selecting that board. Next and click on finish. Now it automatically opened this window. Click on plus symbol and click on add or create design file. Click next and click on create files. Now type the file name, click OK and finish. Here my inputs are clock and enable and reset, and output is Q and it is 32-bit length, so I am choosing bus, and MSB is 31, 2 and LSB is 0. Click on OK. Next we can observe that it is updating, so open design source, click on counter, and now here we can observe that module counter inputs are clock, enable and reset. Output is 31 to 0 Q, but it is a sequential circuit, so we have to use register. We know that FPGAs operate at a very high clock speed, so we can't observe output as 1, 2, 3, 4 like that. We will observe some random numbers, but in a increment or decrement way. So now we are using clock D and div register for clock division. Here clock D generates a slower clock signal. This slower clock updates clock D is preventing it from counting too fast. Now here always at the rate pause edge clock D and begin. If reset is high, set Q is equal to 0, and if enable is high, so up counter, so Q less than or equal to Q plus 1, else it means if enable is 0, then decrement and save it. Now in IP integrator we will see that create block design, so click on add and drag and drop that counter. Here we observe that it is a 32-bit counter, and click on add symbol and search VIO ports, and again click on add symbol and search for ILA. Click on clock and make it external. Now here number of inputs of counter is equal to number of outputs of VIO ports, and number of outputs of counter is equal to inputs of VIO, so vice versa. Double tap on VIO, make it 1 and 2. Click on probe inputs. So here input is the output of the counter, so make it as a 32-bit and go to probe out and leave it as 1 and 1, because the inputs of counter, enable and reset is 1 bit only, and connect those probes with the Q and enable and reset. Now double tap on LA, so select native. Now make number of probes as 3, because number of probes in ILA is equal to sum of inputs and outputs of counter, and we have to change one of probe to 32 bits because our output of a counter is 32 bit, and connect them. After that click on design and click on create HDL wrapper, then click on OK. Now it's generating HDL wrapper. Now again click on add source. Now click on add or create constraint file and give the constraint file name and finish it. Now click on run synthesis. Click on window and click on IO ports. Here we can observe that clock. So give package name as U18 and make it as LV CMOS 33 because 3.3 volt. Save it. Already we created one constraint file, so we are keeping these things in existing file. So here we observe that, and here in device we observe CLB. In that CLB we can observe LUTs and flip-flops and marks. Next click on generate bit stream and I'm directly clicking on auto connect. If you are connecting new, then click on open new target and connect the board. Now click on program device and program and select all of them. Here my reset pin is 1, so output is 0. Prob out 0 is reset pin and prob out 1 is enable pin. Here I am making enable pin as 1 and reset pin as 0, so that here we are observing that it is increasing. When I make enable pin as 0, we can observe that it is decreasing, so down counter. Again when I make reset as 1, it is 0.